Hi there, Chloe. So, project. So, you were going to look at the correlation between the self-efficacy and the marks on the module. So, you've got the spreadsheet that we sent you before, but there's a copy of it in the box folder. The way that I'd like you using R, I've used it before. To start with, but I've set it up so that it should be fairly forward for you. So on a university computer, if you just go to the programs that are on there, you're looking for R. It might say RX64, but R should be installed on all the university computers. So when you open it up, you get something that looks like this. So what you want to do to start with is to go open script, and you want to open the script that I've sent you via box. So it's that UG self-efficacy Chloe, and what you'll script that tells R how to do its analysis. Okay. Now the way that I've set this up is anything that's got hash marks at the front is a comment, so that doesn't actually do anything. That's just documentation, tells you what's going on. So there's actually description with these hash marks. So no, then that's an actual command for R. Okay, and to run each command, what you need to do is to put your cursor to, and then press Control R, and that will allow it to do so. So what to import the data file. Then it opens up a window. Okay, so what it's going to do, so that's what this file choose means. So it's choose a file, then it's going to read it and then call it just within our, it's just going to call it data. So if I find the spreadsheet that we've got, so I've sent you a copy of UG Self-Efficacy Chloe CSV. Okay, so that's now, you can see that that's read it, so because it's put a red text in the window on the left hand side. But we want to check that it's imported it through. So if I now move to this function here, it says names data, and just click, have my cursor there and click Control R, then it gives me a summary of all of the different column names in the data sheet. Okay, so you can see that it has imported it successfully. Then I can do this structure data, so that gives us a little bit more information. So if I just show you that, then it shows us, for example, that when we look at the module mark here, then it says that it gives us an integer, so it gives us a number, and it gives us an example of the types of numbers that are there. Okay, whereas if we look at, for example, gender at the end, then it tells us that that's a factor, and there are 4 levels. So we have male, female, not stated, and non-binary in there. So that gives you an idea of the structure of your data overall, and it tells you how many observations we've got. So we've got 64 observations in total. Okay, so first of all, what we need to do is some descriptive statistics. So I'm going to use the example of looking at the relationship between the mark on the module with the overall foundation. So yes, mark. So you will need to substitute this to look at the look at the relationship between the mark on the module and the self-efficacy. So you'll need to change this code in order to do it. So let's have a look at this to start with. So the first thing I'd like to do, let's say I want to find the mean module mark for module 06061, so that's the module mark. So the way that it sets up, so it's mean, okay, and then in the brackets this is what it's going to look for. So data is the entire spreadsheet, and then what's after the $ is the column that it's going to use. So I'm interested in the module mark, that's what that column is, so that's there. So if you want to change this, so when you've got your total self-efficacy score, for example, then you'll need to change the name of the column here to match. Okay, so if I then click R, I can now find that I've got the mean, so the average mark on the module was 63.7%. Okay, so I can do the same for standard deviation with this function here, and I can just check how many observations I've got there. So I've got 64 data points in there. Okay, and then in the script I've told you, given you examples of how you'd write that up in your analysis. Okay, so now what we need to do is to do some statistical analysis of our data. So we're going to do a correlation design, okay, but there are two different types of correlation. We need to determine which one to use. So the first thing we've got to do is to run what's called a Shapiro test, which says tells us whether the data is normally distributed or not. Okay, so if their Shapiro test. So what this is asking is the data normally distributed? Okay, we can see that we've got a p-value there of a very small number. Okay, so what that tells us is our data is not normally distributed. Okay, so it's failed the Shapiro test. It's significantly different to a normal distribution. So our data are not normally distributed. So I've given you the methods for two different types of correlation in here. So here, our data are not normally distribution, so we need to use something called a Spearman's correlation. Okay, so the way that we do this, here's the code here. So we're going to ask for a correlation between the module mark and the foundation year mark, and we're telling it we want the method Spearman because it's not normally distributed. If I click that, then that gives us the degree of correlation, so 0.7. So that's a reasonably strong positive correlation. And we can do that a little bit more in depth. So if we do core.test, then we can get not only that, but we can also get a probability value. So the probability is that there is no, so testing is there that there's no correlation. So we've got a highly significant p-value there. So we do have a significant correlation between the two. Okay, and again, I've given you an example how to write that up in the script. Okay, so that's our statistical analysis. So you'll need to edit this code in order to look at the correlation between the module mark and the self-efficacy. Then we have a graph of the data. So here we've got the code for drawing a very basic. If I run that, and if you've got multiple lines of code, just highlight all and then click Control-R while they're all highlighted. So you can see there's a correlation between the two things, but this is a pretty basic scatter plot. You can see it's got a fairly hideous label on the axis there. It doesn't go up to 100%. We could make that nicer. Okay, so I've given you some code to do this. So if we just highlight all of that, okay. So there's a nicer graph. So I've got the correct labels on the axis, and I've put in a label to put the statistics on there. So when you do yours, you'll need to, in this label here, you'll need to swap in and just type in the relevant values for your data. So this was for this particular correlation, but when you've done that analysis earlier on, you'll need to substitute those values in for your data. If you want to do some slightly more sophisticated analysis, you might want to think about doing things by multiple groups, for example. So I can do, again, I've given you the code for this. So this code, if I just run that, then that code will separate it by gender. So the correlation's for the whole data set, but we've picked out females in black and males in red, and the other two in other colours. Okay, so there's an example of a slightly more sophisticated graph if you want to do some more sophisticated analysis. To export your graph, if you just right-click on the graph and just click Copy as Meta File, then when you go into Word, so here's your Word document, then if you just put that in there, then you can paste that in, and now you've got your graph. You can then scale it as normal. So that's now got your nice quality figure from R into your graph, into your Word document. Okay, I've given you an example of how to write the statistical methods, an example of figure caption, and an example of how to write that in the main body of your results. So hopefully that's going to allow you to get going on your data analysis. Yeah, so just you want to do the same thing, but to test the correlation between the self-efficacy and the mark on the module. So you'll need to substitute your values in the code.